Hi guys, in this video I'm going to be talking about combinations. The idea behind combinations, it's really similar to permutations, but this time order isn't important. So in other words, like if I have a group of 10 people and I need to pull 3 of them out to go do something, I don't care who I call first, second, or third. I just need a group of 3. In that case, it's different than having like gold, silver, bronze, where order is important. And so we're going to treat it a little bit differently, and that's called a combination. So combinations, order is not important. There is a different formula for that. So notice the formula for permutations was just this, n over n minus r factorials for both. And for NCR, we add this little piece to the end. And that's all fine and dandy. And I'll walk through solving them by hand so we can do them the long way for notes. But really, you have an NCR button on your calculator. And you can find it by going to the math menu. And you can go over to probabilities and you'll see it here. It's option 3, right? So you can always use the NCR button. N in this case is going to stand for the size of the group, right? How many things do you have to choose between? And R is how many do you want? How many are you interested, right? So in my previous example, whenever I said if I had a group of 10 people and I wanted to pull 3 of those out, I would say 10 NCR 3. And in that case, 10 NCR 3 would give me 120 different ways that I could pull 3 random people out of a group of 10. Okay, so that's kind of what we're talking about. And what we're going to do then is discuss in this video how to find the number of combinations. So I guess I need to erase. I'll change that before I print off the notes for you guys. Finding the number of combinations. Standard problems are going to deal with things like playing cards and die and heads and tails on a coin, things like that, okay? Standard deck of cards has 52 cards in it. Those 52 cards are 4 different suits. You have diamonds, you have clubs, you have spades, and you have, hearts. And there are 13 different cards in each suit. There's 2 through 9, 2 through 10. And then there's Jack, Queen, King, and Ace, right? Hopefully that's not new information to you. If not, you have not played cards very often. And the question is this: if I'm going to play poker, everybody gets 5 cards at a time in poker, how many different 5-card hands are possible in a game of poker? Well, here's the deal. If I'm holding my poker hand, okay, and I have 5 cards, and those 5 cards happen to be the 9, 10, Jack, Queen, and King, that's a pretty darn good hand, okay? And so I don't really care if the 9 is this card in my hand, or if the 9 is this card in my hand, or if the 9 is this card in my hand. I really don't care which one it is. In other words, order is not important. I don't care what order I'm holding my cards. All I care about is which 5 cards do I have. So that's the first thing we got to determine, is if order is important. And in this case, the answer is no. So how we figure out the number of 5-card hands is by simply doing this. We say, how many things, it's C because order doesn't matter, how many things do I have to choose between? I have 52 cards to choose from. How many cards am I going to choose at a time? I'm going to choose 5 cards at a time. So if I put 52 in CR5 on my calculator, it's going to give me a pretty big number. It's 2,598,960. I guess here, I'll show it to you. I did it beforehand. Ready? 52, math menu, probabilities, NCR, 5. 2,598,960 different hands available in the game of poker with a standard deck. So that's all fine and dandy. I hope that makes sense. And what I want to do here is, before I quit this video, I want to show you a more difficult example. Okay, so same problem, 52 card playing deck, and how many of those 5-card hands? How many of those are all 5 cards the same color? And we get something a little bit different here. We have to adjust for the color, so either it's red or it's black, right? And so I'm going to add in a second piece. So we do have the 52 in CR 5, and that's going to be part of the problem. But we have to make an adjustment. Oh, I'm sorry. We're not going to do that. Ready? What we're going to do is we're going to say this instead. First of all, I have to choose the color. It's either red or it's black. And so what I'm going to do then is I need to do, and I don't care which one I have, but it's going to be 2 in CR 1. I have 2 choices, 2 colors. I need to choose one. And then I'm going to multiply, and we'll discover why we're multiplying in later videos, okay? For now, just understand I would have to multiply by the 26 remaining cards that I have to choose from, either red or black, I don't care which one, but half of the 52, and I'm going to choose 5 of those cards at a time. So I have this part right here adjusts for the color. It's either red or black. And this part here adjusts for the fact that out of the 26 red or the 26 black, I want to take 5 at a time. And so I'm going to get these two values and I'm going to multiply them together. So here we go. What is 2 colors, 1 chosen at a time? It's 2. Okay. What is 26 cards chosen 5 at a time? It's 65,780. And so I take those two and I multiply them together. So if I double the 65,000, I end up with 131,560 different ways now notice 2 million, 2.5 million, almost 2.6 million ways you can get a 5-card hand. Out of those, 131,000 of them will be all of the same color. So that's a more difficult example. And before I go into that fully, why did I multiply and how did I do that? All I want you to understand is sometimes it gets a little more complicated. We can do more than one combination at a time. We're going to talk in the next video about how to add or multiply and how I know. Okay? And so I'll cover that in video number 2.